Welcome back, everybody. This is an extension of section 9.1, introducing the hypothesis testing. And very specifically, we're going to talk about beta, the type 2 error that I briefly talked about in part 1, and how to calculate it, as well as how to calculate the power of a test. All right, so let's review for just a second. The type 1 error is denoted by alpha. Now, alpha is pretty out there, right? It's almost given to you in almost every problem that we have. And the type 1 error consists of rejecting the null hypothesis when the null is true, right? So if we were to reject the null hypothesis when the null is true, we would have a type 1 error. And those type 1 errors are usually pretty, the probability of them is usually pretty small. We have alpha equal 0.01, alpha equaling 0.05. So it'd be 95, 90, 99% sure that you were correct, but you would be holding out that 1, 5, or 10% that you could be wrong. All right. And like I said, the alpha is usually in almost every question that you have. All right, so the type 2 error, that's the one we're talking about today. All right, is denoted by beta. Okay, and that consists of not rejecting the null when the null is false. Not rejecting the null when the null is false. Again, it's definitely an error because if the null is false, you want to reject it. But, this error can happen. Now, the power of a test. All right, very simple formula would be 1 minus beta. Okay, so whatever beta is, just remember beta is a probability, so it'll be between 0 and 1. All right, so it's 1 minus the probability of a type 2 error gives you the power of the test. All right, so let's go straight. This is how you would calculate the power of a test if you wanted to go there directly. Might be a little bit confusing to me when I was sitting in your chair, but I'm going to try to explain it as best as I can. All right, I'm going to use an example to try to help. All right, so suppose we are about to sample 16 values. All right, so n equals 16 from a normally distributed population where our sigma equals 8, but mu is unknown. All right. So let's say we decided that our null hypothesis was that mu equaled 75, and our alternative was that mu didn't equal 75. All right, so right off the bat, we know it's a two-tailed test. Okay, we're going to come back around to that in a little bit. All right, so we also know that since we have our standard deviation of the population known, our z formula is x bar minus mu over our sigma divided by the square root of n. And what I want to know is for what values of z do we reject the null? Okay. Now, the other piece of information we want to know is we need to know alpha. in order to do that. I'm going to put alpha at 0.05. All right. So let's see. All right. So let's draw a quick picture. All right. Two-tailed test. So here I've got 0.025. Here I got 0.025. And in here I got the do not reject. All right. So we know from our alpha that we reject if negative, right? We know that our critical values are 1.96 and negative 1.96. And we know that we reject if our test value is going to be less than or equal to negative 1.96, or our test value be greater than or equal, right? Greater than 1.96. All right. So now we've got to figure out what our average has got to be, what our X bar's got to be in order to get the above situation to occur. So here's the way we're going to figure it out. I've got X bar minus R75, which is our mu, right? That's what's right in the middle here, right? Divided by 8 square root of 16 is less than or equal to negative 1.96. And I want to figure it out on the other end as well. X bar minus 75 over 8 divided by the square root of 16 is greater than or equal to 1.96. What I want to do is I want to bring it out of Z. Remember, Z is our standardized units of measure, and I want to bring them back into whatever units we're using. If we're doing heart rate, or we're doing, you know, average boxes or time or something like that. So why don't you pause the video real quick and figure out what each of the X bars are, and we'll come back around in just a second. Okay, hopefully you paused the video. I got X bar has to be less than or equal to 71.08. And I got this X bar has got to be greater than or equal to 78.92. Hopefully you got the same thing. All right, so let's make another quick graph. Remember, my 75 is right in the middle. And instead of using my Z's, I'm just going to put in my other units. All right. So now I'm going to add a piece of information to this. What if we knew that mu equaled not 75, just kidding, because that would mean that we would be right if we did not reject. So let's say, and this is an added piece of information that you have to know in the problem in order to get either beta or the power of the test. So if we knew that mu was 76, all right, how would we get the power of the test? So this is the question that we're going to answer. All right, I'm going to try to help with the drawing and then help with the problem. All right, so I'm going to use a different color. What if, right, I'm going to redraw All right, not the greatest drawing in the world. Let's try that again. So let's say, okay, so I'm going to come up from here. Okay. Extend that. All right, so let's say, so there's 76. What we actually need to look for is that piece and that piece. That's what we're looking for. All right, in order to get the power of the test. All right, so let's see if we can complete this problem. All right, so I want to know the probability that x bar is less than or equal to 71.08 given that mu equals 76. All right, and again, standard deviation is 8. Our sample size is 16. So let's get our z value. It's going to be 71.08 minus 76 over 8 divided by the square root of 16. And I got a z value less than or equal to negative 2.46. If you want, you're certainly welcome to pause the video and check my work. I would say pause the video anyway, because you need to take that negative 2.46, which would be on this side of the graph, and get the area to the left. All right, I'll come back around, I'll give you the area. All right, so you looked up the area. I got it equaling 0.0069. And again, those z charts cut off at different decimal places. So if yours cuts off at a different decimal place, that's fine. It should be very, very close to that. All right, so now let's do the right side. All right, I need to know the probability that x bar is greater than or equal to 78.92, given that mu equals 76. All right, and so my z is 78.92 minus 76 over 8 divided by the square root of 16. And again, I got z has to be greater than or equal to 1.46. All right, again, when you pause the video, you're certainly welcome to check my work. But now we need to know area to the right. So we need to look up right. And so pause the video, look up the area to the right, hit play again when you have it. All right, so I got the area to the right being 0.0721. All right, 1 minus the area that you saw on your chart. So the power of my test, remember, we were always looking for the power of the test. Is going to equal 0.0721, and then I'm going to add 0.0069, and I get 0.079 as the power of my test. Now, if my, right, now also what I can do is I can get the probability of a type 2 error from this, which would be 1 minus power of the test. So that's 1 minus 0.00 0.079, and I get 0.921 as my probability of a type 2 error. All right, the second and final example we're going to do, we're going to use a lot of the same information. We're just going to find the probability of a type 2 error and then do 1 minus that to get the power of our test. So I'm going to say, what if we know that mu actually equaled 77? What is the probability of a type 2 error? All right. So we already know that if x bar falls between 71.08 and 78.92, we do not reject, right? So, and a type 2 error means we do not reject when mu is false, right? So we think mu is, right? We think mu equals 75. That's our HO still, right? But now we know that that's false. So we need to find out what x bar, right? We need to find an x bar in between 71.08 and 78.92. All right, so I'm going to say that that would be I'm going to put it into my Z formula. (78.92) minus 77, 8 divided by the square root of 16. And I'm going to ask you to pause the video for just a minute, do both calculations, and then we'll move on from there. All right, so the numbers I got, I said, so we need to know the probability, right, that Z is going to be in between negative 2.96 and 0.96. And we've done these kind of problems before with the chart, right? So we need to get the area in between, all right? So this will be good review for you guys. Why don't you guys pause the video, take a moment to look up your area values on the chart to get the area in between, and we'll talk about the answer in just a minute. All right, so I got the area in between to equal 0.830. All right, and again, this would be, again, the number of decimal places could fluctuate depending on what chart you're using. You have more decimal places than mine, it will go out further. This, is just where my chart goes. So I am basically saying that this is the probability that I will not reject given that HO equals 77, meaning false, right? Because our original theory was, our null hypothesis was that mu equaled 75, and we know that's wrong. So we will not reject, even though the null hypothesis is wrong. So I can call that another thing. I call that a type 2 error. So that would be not 8, 0.830. All right, so then the power of the test (1 minus 0.830). So the power of the test equals 0.170. There you go. 2 very quick examples to kind of show you. I think it's easier to go from the type 2 error. It's probably more inclined from where you're coming from. So I would focus on that. But there are some additional examples in your homework that you should try out as well. And thank you for listening, and I'll see you soon.